Hey guys, welcome back. This is the episode 34 of the peer-to-peer network. Um, at this episode, what we're going to do is to check what happens with the events that come from the network into the client side, um, where they become available to be processed. Okay, so my guess is that they are arriving, but probably they are not getting processed in any way. So let's go into that. Okay, so this is the broadcasting function that is actually broadcasting to clients. Okay, so from here I will need the desktop app. Oh, look, this is exactly what I was suspecting, that when they arrive, this is from our last episode, that we sent a message, stuff, and it was halted here. Okay, so what we have is essentially a module. Let me first commit our previous work. This is il- okay. So we have this at the social trading application. We have this peer-to-peer network interface. Okay, um, which is the place where this message arrive. Event receive is here. But also, I want to know what happens inside this guy, the WebSockets client. This is a network module. Okay, we have even received. Okay, so here is the function. Let's check it out. So this goes here, this goes here, this goes here. Okay. So I think I closed something that I didn't mean to. Okay, so these events come through here. Okay, on message, we get this function that is going to resolve or reject the promise given. What are we talking about? Okay, so there is a message ID mechanism. When there is an answer of a call, we will receive a message ID and we have the function that is going to process that. So if the function is not undefined, then we delete the function and execute the function. Okay, so the message, when we are here, the message received is not a response to a message sent. That means that it is a notification received from the network node on an event or signal that happened at some other client of the network. This can only happen when this model is running at an app like or tag server app. Okay, so because the WebSocket network client is also running at the network node, so be careful with that. Okay. So we have message, event message. So what's going on? You have a message. So this is how we distinguish if it is a signal or an event or whatever. It seems that we will have event message. Okay. Okay, so we parse the message. Hold on, I'm trying to figure out what is going on. So we parse the data package. If we have an ID, this is going there. So I'm going to organize this a little bit more. I'm going to say function process answer to a request. And then we will have a function that is going to be process. We will call it notification. You're being notified of something that happened. Okay, so this guy is going to come inside here, and this is going to be called from here, and this other guy is going to be inside here, and this is going to be called from here. As you can see, there is no really actually a need to do this, but it's just to make the code clear and easier to understand. Okay, so now we have two functions: process and answer to a request, or process a notification. Okay, then what do we get here? An event message. I want to make the comparison with what is going on when we receive a message here. There is a message type. Okay, so I want to know Let's run this. I want to know exactly what we have here. So I'm going to run this guy. So post, and we have this here. So the message that I receive, it has a request type. So I don't need to check for this to be undefined or not. But most importantly, it means that this is what we used to call the message header. Okay, the message header. Now we have to segregate by network service, the same that we are doing there at the other side, and then by request type. And depending on that, we are going to send this inner or to another layer up the stack, because now we are at the stack at the layer of the WebSocket network client. Okay, so we don't want here to have logic of other network services beyond the discovery of which is the network service. We need to forward this to. Okay, so what I was trying to do with this is, yeah, this is not the way we have to do this. So I'm going to stop this and see how we're going to deal with this in a similar way to this stuff. Okay, the first thing I'm going to do is to standardize this, and I'm going to call this message header because this is how it's being called everywhere. Okay, so here, message header, message header, message header, message header. Okay, so now we are better. Now let's check this. So we will need to run more or less the same validation. We will not need a handshake here, but we will need a network service to exist. And base probably we can do with this switch. Okay, if um, so what happened if the message header is none of these guys? Let's create a default. Network service not supported. Okay. This will be really more useful here. And here. So in this case, what are we going to do with the failure in this case? Because there's nobody to call to or to respond to. So probably we're going to log a warning. Okay, very unlikely that we have this situation, but if we do, now we will know what's going on. So at the at the node we have several services running. So here we will have something like this. It will be the social graph network service client not running. Okay, this will be enough to know what is going on. Okay, so this peer-to-peer network interface as a service of, okay, so we need this guy, the social network service client. Who is creating this guy? Oh my god. Who is this peer-to-peer network client? Okay, so this is the module that concentrated all these guys. This is where we will process all the event coming from the peer-to-peer network. Okay, so we are creating with this guy, and this is the service. Okay, okay, so this is incorrect here. The reason why is because this is a network. This represents the network client, and inside it has these network services. Okay, so far it runs all these network services that, by the way, it shouldn't, because well, yeah, for now it ran them all. Okay, but that's not the point. The point is that this belongs, oh, why do we need this inside here? So my question is now, is this really peer-to-peer network interface a node of social trading? Yeah, it is. Why do we need this guy here? because at the socket client we need WebSocket client. We are sending this. So that eventually can send a message to there. How does this work at the network? So what we actually need is not a reference to that guy, but a reference to the peer-to-peer network client itself. Because from there, that is independent of if it is a desktop app or task server app or whatever. But so from there, I can get what I need. So I'm going to correct this. Connect to that here is going to be peer-to-peer network. Not the interface, but network client. And from here, this is going to be passed on to the WebSockets network client. Where we will have just the peer-to-peer network client. And with this guy, we will be able to call whatever we want, okay? But then here, we don't need this guy inside here. It doesn't belong here. This should be inside this event. There is the social graph network service client. Okay, social graph network service client. When we initialize this guy, we bootstrap and then we do this. And then we initialize this guy, whatever that means. Okay. But this means that here we will need this guy undefined here, and we need to undefine it here. And we initialize it here. Handle the social graph network service client. So that means that at this place the network interface is non-existent anymore. So this will be instantiated. From here we will send a reference to the same client so as to from there be able to have this object social graph whenever we are here. And here social graph, the interface, and we can send a message received. Forget about signals. This is not going to process signals. So this initialize with the user app is not true. Because we are going to send stuff to the networks directly to this network service client, whatever that is. So we don't have signal receive. We just have message receive, message receive. And what is this? Peer-to-peer network interface. We don't need you. So this model handled incoming messages that are not responsive to requests sent, meaning notifications. This is the case for any kind of event happening an entity followed by the user profile by some social entity belonging to the user profile running this app. Okay, so now we have this here. Okay, so we change the structure of how these modules are interacting with each other. We will have the network client sending a reference to itself to connect it so that at each WebSocket client we have this reference to itself. From there we can get the reference to social graph service client and then the interface that is going to allow the incoming messages to start going upstream. Okay, so the WebSockets client is where we are working now. So essentially what we have is that if the message header is a social graph network service, then we're going to ask if this guy is not undefined, because later we could add a feature to specify which which network service client we want to run starting up, but now it's not parametric. But anyways, so if this is not undefined, then we are going to send a message in this way. We're going to send the message payload because then we don't need the message header anymore. And all of the other stuff is irrelevant to us. Else, this is going to be shown there. Okay, and all this stuff that was old, we can get rid of it. Probably we don't need this or this. So very simple now. And this should bring us the message specifically inside here. So the only type of message we can have here are events. So this is going to be an event message. Okay. Or let me check out on the network side. Client interface. This is receiving. No, in fact, it's receiving something like this. Message received. So we are also going to run, because we are at this level now, similar to the client interface, okay? So we will receive a message here, a message. And then we're going to do like this. We are going to parse the message, see the request type, this signal is not a valid request type. And this is also probably here. Okay, not there. But in our case, it's only going to be acceptable an event. So then we're going to execute a function event receive. Okay. With an event message that we're going to parse again. Maybe run some validations. Okay, let's check this out. So message. We'll copy this and adapt it. So when a message is received, we're going to parse it into the message header. But if anything goes wrong, we are going to create a warning where we are going to say peer-to-peer network interface um, message not correct JSON format. Okay. Then again, request type not provided. It's very strange that we reach this stuff, but nobody knows. Okay, probably I should have a return here so that we don't execute more than needed. So if this is not an event, it's the only kind of thing that can arrive here. We are going to say request type is not supported. Okay. Then, because the event is the only request type, then we don't need to do this switch. So for sure we will not have this problem. And I'm not sure that I even have to call another function here. Maybe not. So what this guy do here is to call the function even receive. Okay, I will call the function because we are passing the even message. We don't need this to be an async function because we are not going to await for this. That means that here we're not going to await for this either. So what happens here? for sure we will not have this. We don't need this commentary. So even receive, we're going to parse it, and if we cannot parse it, we're going to say something similar to this. Even message, not in the correct JSON format. So here we have to ask ourselves, what are we going to check before considering this a valid event? Probably the same validations that every node checks. The signatures, that the social entity exists. Okay, the client interface needs to be okay. So there is no requirement that the event has to be emitted by anybody in particular. Okay, there's no requirement for that. But still, we will probably need this. So let's scan the code. We will check the social entity exists. Okay. Get the user profile that has those social entities. Okay, so this validation for sure not. Okay, there's a problem here. We are tracking events as if it is a network problem, but events are not on the domain of the network. They are part of the social graph network service. So this stuff is not correct. I will take this note here. But anyways, we will also keep a map with the events that we receive so as not to process the same event more than once, because we might be connected to multiple network nodes. Okay, we have already received this same event, so just ignore it. So now I want to use signature validations, but I cannot do it because it's not it's not SA but NT. Okay. So I cannot use this here unless I change it. Okay. Here will we process the event and change the state of the social graph. So let event equals to okay. Okay, so we have an idea of the problems we need to solve. So which is what we're going to keep or not? Social entity ID. We need it for this. Social entity. Filter followers from user profiles. No, we don't need you. We don't need to filter this. We don't need to filter this, and probably we don't need to do anything that is in here. Well, we are going to do this. We will add this to the maps of events. Add this event, the local map of events process, and whatever is coming here, we don't need you. So again, social entity, it seems that we don't need the social entity. Unless we use this to hook somehow. Unless we execute here. a function. Social entity dot event receive, and we pass the event receive is this guy. So the only thing what I will be requesting the guys doing the desktop app or whatever app is place a function callback. No, because this is a social entity producing the event. So no, I need a way to send the event to these guys. And then they should figure out how do I make this reach the desktop app, because the desktop app has hold on, we'll do it like this. Look, function event arrived. Event arrived. Okay, so here we're going to add event arrived. This is the function that is going to be executed. Also log this event has just arrived from the peer-to-peer network. JSON stringify event. Okay, so the event, we are making the event go upstream until it reaches this point. Once it is here, it's up to the guys doing the user interface or the whatever business logic they have to do with the event whatever they want. Okay, so I'm going to send this function in here. That is going to translate to having a function in here. Subject even arrive. Okay, so essentially then at this guy interface, we need the callback function. So how do I get the callback function? One way is to get it here. This is going to end up executing here. Put a breakpoint there. But we will need okay. So whoever is using this, the only thing they need to do is to initialize the peer-to-peer network client, and they will receive events related to this desktop app signing account and user profile through this function. And from here, you can do whatever you want with that. Okay? That's the trick here. And this is what it closes the whole cycle. It closes the whole cycle. Give me a second. Uh, okay. So this finished the process. So what do we have pending to solve this problem? Here at the peer-to-peer network interface, what we have is this signature validations. So it's social trading. NT utilities event signature validation. So the mistake here was to believe that this module was going to be used only at the network, but the signature validation is a problem from everyone, including the one that receive an event as a notification. You need to verify who is sending you this. Otherwise, the node that you're connected to can inject you with events that are not real. Okay, so you need to, in order to process those events, you need this. Okay, so for that means that here SA we have globals but not utilities. Okay, so signature validations, you're going to move it also at the profile schema. That means that we're going to copy the whole utility stuff, remove it from here, SA module globals, and utilities. And then event signature validations. Okay? Next thing to do is check for this string everywhere. So we will use this guy. Okay, so first problem solve. We send the event receive and the signature. Good. So signature validations problem solved. Then product network global memory events map belong to the social graph, not network. Okay. So this map events Um, we are talking about network NT, network project. Okay, so these two things, but at least events, are not supposed to be here because the events are not belonging to the network project. These are belonging to the social graph. So events there, and events memory. We will have a similar problem later with signals, but now I don't want to change that stuff. Okay. So because we move this, we will search for this string. Okay. And now this will be social trading. Okay. Then here we go. Then we finish with this point too. Okay, so we finish the coding of all our stuff apparently. So it's time to test it. To test, we're going to run the network and hope everything is still running. Oops, not so quickly. Okay, it's not. What is going on? Oh, okay. Cannot read properties of undefined reading maps. So I also need to change this guy, but I need an example of this. Social trading, globals, memory map. What is wrong? It's not NT, but it's SA. Okay, so we need to change this including events. With SA. But also we need to change this guy for social trading SA. Okay, so let's see, let's run it now. Okay, so on the desktop side we will put a breakpoint like here, and also here, and we will run this guy, see how it goes. Okay, we don't need a message here, but here. No, here. Okay, I'm going to type, this is my third post. So service social graph. Okay. Hold on. We were supposed to send this payload. Message header payload. What is a payload? Message header, even message. Okay, even message. And here the callback function. But I don't see that we are receiving this here. Because the callback function is supposed to be inside here. This doesn't need to be an asynchronic function, and doesn't even need to be outside this. Also, there is no user profile. And also, it doesn't even need to be another function. But let's say for now that it is another function. Let's go again. Okay, message receive and callback function. Request type is undefined. What is why? Network service, social graph. So where did we get that this is an event? Okay, this shouldn't be like this, but just a message header. So what exactly is that what we are doing here? Message header payload. So the client interface receives this, okay. So when we are here, socket message, we got a message header. Social graph. But if we see it here, we are sending message header payload. So what is wrong with what I'm doing? Okay, so now I don't have a payload here. I have an event message. But when do we change that? When did we change that? I'm struggling to find out why it's not symmetrical. So the WebSocket interface here, when we are broadcasting this, why are we sending the payload? Probably that's the problem. Why don't I send just this guy? Um, hmm. Okay, now we have a message ID, and now we have a payload. Okay, so this have more sense. This message is similar to the other guy, and now we have hold on. Why we have the network service here and inside the other stuff? Something is not okay. Here we have a message type request. Network service social trading graph, and this is the payload that we specify the network service, blah blah blah. But when we parse this, we also have the network service. So who is putting the network service twice? Social graph, network service client, query. Who is putting the network service? Okay. Let's see first if this is working, but I will take a note. Who is putting network service twice? Okay, so this is undefined? No. It is event? Yes. Do we have a signature? Yes. Do we have an event message? Yes. So if we run this, then the event received is this. Hold on. The network service is also inside the event. So it's 3 times. Is here. Okay. Social entity ID. The social entity, probably we don't need it. But it's not bad to, because why would I want to process an event of a social entity that doesn't really exist? That doesn't make sense. So I'm going to check that. So user profile, get the user profile that has those social entities. Okay. We will accept events that don't have an event ID. Yes. Do we have events processed? No. So check the signature. We have ever received and signature. Response undefined. So we are going to set. Okay, here I don't have an event. So this is going to fail. Okay, so here event received. Do we want to store a lot of information at the events? Probably not. Just true for now. So we are almost there. But I want to know who is adding network service all the way at all levels. So if it's not you, who is the guy adding this stuff more than once? Mm. Okay, probably it's me because I'm adding it here, here, here. Yes, it's me. So I don't need to be here. Um, Probably. Because at the WebSockets is where we need the WebSocket message. Is where we need to know which is the network service. Okay, not inside everywhere here. So my guess is that this is not needed. This is not needed. This is not needed. And this is not needed. But WebSocket, by the way, this is not a place to have this module. Okay, so who is this guy? Web social trading UI. Let me see if with this change I receive here the network service stuff. Let me check that. What is okay, somewhere I'm checking and network service not supported. Okay, so we have the WebSockets interface. Okay, so what I'm going to do is I'm going to revert this change. Let this work. And I'm going to leave that as a pending task to resolve, because this also opens the question of, if you are not using the WebSockets interface at the client side, then how do you send the messages? Okay, so that's one stuff for me. I'm going to do the debug without this. This is going to be a pending task for another episode. So I have the network running. So I'm going to run the desktop. Not stop this here. I'm going to write yet another post, 8th post. So we can move from here to here and go through all the stuff. Set this at the event map and call this guy. What happened here? Even receive is not a function. Okay, you're right. This was not a function. This is a function. So let's run this again. From here. Ninth post. Message received. And voila. Okay. So to recap, there was a lot of work pending on the side of the client when an event was received from the peer-to-peer network. We didn't upgrade this to take into account that there are more than one network service now, and that we need to have a network service client, and to transport this event to a place where the users of the client, or the network client, can receive the information and then do whatever they want with that. Okay, so there was a lot of stuff there to do, but now it's working. So in the next episode, I'm going to dig a little bit further on how the user of this client are going to put message through if they don't want to actually use WebSockets as a way to inject the messages. So I need to create an interface so that it bypasses the WebSockets that is listening for messages from a web browser. Okay, so that is one thing that I need to do in order for this guy to be able to send message via that mechanism. Okay, so thank you for watching this one, and see you next time.